We have 2x squared minus 20, wait, no. Yeah, minus 20 equals 3x.
I'm sorry, 2x squared
Minus 20 equals negative 3x.
Okay, how are we going to do this one?
This one doesn't factor, right? Or does this one factor?
Oh, we don't know. It is of the form that would be a normal quadratic equation. In other words, we're looking for an x squared term, we're looking for an x term, and we're looking for a constant. When
X squared.
you do that, then put everything on the same side, and then we take it from there.
Okay, so would we add 3x? Okay.
Because you always want one side to say 0 if you're going to solve it as a normal quadratic.
Okay.
Sunny, lay down.
Yeah.
Lay down. Okay. Now we have to determine whether we can factor it or not. And I'm betting it probably does factor. We haven't seen any yet that require the quadratic formula. Start me off. This is definitely going to be a little tougher to factor because it's got 2. That means it's not an elementary factoring one. It's a trial and error factoring one. But we certainly know how to break up the x's. What are the x's?
So it's x in the front. Would it be 2x in the first one and then just x, or?
Yeah, or vice versa. It doesn't matter.
Okay. Yeah.
It can only be broken up as 2x and x. Now, what are the signs? What's the second?
Positive and negative.
Okay, now because the coefficients are different here, then plus minus is not the same as minus plus. So I have to allow for both of them. I'm going to put both. In other words, it could either be the top scenario where it's plus minus, or it could be a different scenario where it's minus plus. And the only reason that's not the same is because these coefficients are not the same. If the coefficients in front of both x's were the same, then you could just write plus minus.
Okay.
Now, how many factors of 20 do we have? Let's go
we have 1 and 20.
Okay.
We have 2 and 10. 5 and 4. And I think that's it.
I think that's all. So those are the 3 sets of factors we have to work with. Which one should we try it to begin with?
Hold on. I'm just trying to see. 10 and 2?
Always the 2 closest ones together.
The 2 closest ones together, so 5 and 4 then?
5 and 4. And when I say always, that doesn't guarantee that it's going to be the answer. But that's just the way Colorado makes their problems. Even on difficult factoring problems, they give you a little bit of an advantage by making most of them be the 2 factors that are closest together. Okay.
All right.
So I'm going to randomly try 5 there and 4 there and see if we can produce that middle term of plus 3x. Well, what middle term does that combination produce?
So would we FOIL, correct, to get this?
Just the O and the I. That's the only parts we need. Only the O and the I of FOIL produce the middle term. I know I got this term correct. It wasn't that hard to split up 2x squared. And I know I got this term correct. Factors of 20, also not that hard. But the key is producing the middle term. And you produce the middle term with the 2 smiley faces, which is the O and the I of FOIL, the outside and the inside. Well, what's the inside?
Okay. So the inside would be 5x.
What's the outside give you?
The outside would be negative 6x. Or just
multiplying.
Positive or negative 6x.
Negative 8.
Negative 8? Okay.
Negative 4 times 2 is negative 8.
Okay.
Okay. Now, when you add those 2 together, you get minus 3x. So that's not the correct answer. Plus 5 and minus 4. But
so
I got the right number. The wrong sign is all I got to do is drop that 5 down to here. Drop the 4 down to there. Now when I check the inside, I got minus 5x. When I check the outside, I got plus 8x. Add them together, I got plus 3x, got my answer.
Okay.
The answer is 2x minus 5 times x plus 4 equals 0. We're not quite done yet.
Okay.
In other words, they want me to solve it for x.
Alrighty. Would we take the x, or can we, to solve for x, we just make all the x's 0, right? Or is that to solve for y?
X is 0. You make each thing that's being multiplied 0.
That's right, okay.
Okay? So tell me
So then we'd have 2x minus 5 equals 0?
Right. That's what has to be 0. Which gives you...
Okay. That makes sense. So then we have
probably better
2x.
to solve these each as you write them. In other words, rather than writing both of them, just solve that. If 2x minus 5 equals 0, what's x equal to?
2x, x is going to be equal to 5 over 2.
Okay. Now do the other one. X plus 4 equals 0. So what's x equal to?
X equals 4. Negative 4 anyway.
Negative 4. So those are your two solutions.
Okay. That makes sense.
Yeah, and I could have used the quadratic formula to solve this quadratic, but like I said, so far we haven't seen any like that. So you don't tend to want to use the quadratic formula if you don't have to. In other words,
Alrighty.
if you can factor something, you want to give it a shot first, if you think it can be factored.
Okay.
What else?
We have negative 2x squared and plus 5x minus 1 equals 0.
Okay. Again, standard quadratic, there's an x squared term, there's an x term, there's a number, they're all on one side. There's only one problem. We got a negative sign in front of the x squared term. That is particularly difficult on factoring. So the very first thing you want to do is make that a positive number. How do I do that?
We'd put on the other side.
I could put everything on the other side, but there's really an easier way to do it, and that's divide every term by minus 1.
Okay.
Including that. Okay. Now it becomes 2x squared minus 5x plus 1 equals 0. Notice that all I had to do was just change the signs in front of each of the three terms. You can do that if you have it equal to 0, because that's the same as dividing everything by minus 1. And 0 divided by minus 1 is still 0. So you can always do that. You can always divide every term on the left by any number you want, and it's not going to change the right side of the equation.
Okay.
Okay, now this should be relatively easy to factor because there really are no questions. This isn't even trial and error. Do it.
No, it's just negative 5 and
Step 1?
We have 2x and then x.
Step 2.
Positive or negative, and negative and positive on the other side?
No. You cannot produce a plus 1 if the signs are opposite.
You cannot produce a plus 1 if the signs are opposite.
Remember the last step of FOIL. The last step of FOIL is where you take that number and you multiply it by that number. Well, if they're both negative, you can produce a positive, and if they're both positive, you can produce a positive. But when I'm looking at a plus 1 up here, they have to both be the same. So it has to be minus minus or plus plus. And the way I figure out which it is to look to the sign on the middle term. That's minus, therefore it has to be minus minus. Okay? Now, factors of 1, there are not any choices. If this doesn't work, we're out of luck. Well, guess what? That doesn't work.
So do we have to use the quadratic formula then?
Exactly. In other words, notice the middle term this produces. Minus 1x minus 2x. Well, if you add those
Okay.
together, you get minus 3x. There's no way for me to get to 5. Not when I'm only allowed to deal with factors of 1. So we're going to use the quadratic formula, and to make things easier, let's use it on that, just because there's more positive numbers than negative numbers. Whereas on the original, there were 2 negative numbers and 1 positive. But these
Okay.
2 are the same. I didn't do anything other than divide both sides by -1. So what's A? If I'm using the second one, this one here,
That's 2.
what's B?
-5.
What's C?
1.
And what's the quadratic formula?
Negative b plus or minus the square root of b squared minus 4ac over 2a.
Good, very good. Now substitute in.
So we have positive 5 plus or minus the square root of -5 squared
Which is what?
minus, say what?
What's -5 squared equal to?
25.
Okay.
So 25 minus 4 parentheses 2 parentheses 1 over 2 times 2, so 4.
Okay, now let's simplify this here. Let me scroll down a little bit. There's a little writing room.
So 25 minus 8.
So this is x equal 5 plus or minus. What goes in the radical sign?
We have 25 minus 8.
17 all over 4. Now, that is one way to express both answers. And that's the typical way. But it's very important that you understand what that means. That means x is equal to 2 answers. One of them is the plus, and the other is the minus.
Okay.
There's your 2 answers for x.
Alrighty.
The fact that it comes out with an irrational number, meaning we're taking the square root of a number that we can't reduce to an integer, that merely confirms to us that it couldn't be factored. Because when you can factor something, you always get rational numbers. You don't get irrational numbers. So most of the time that you cannot factor a quadratic like this one, you're going to use the quadratic formula and you're going to end up with answers that are under radical signs virtually every time. Had this turned into a 16, that means I could have factored it.
Yeah, okay.
Now I'm going to get whole numbers as answers for x, which means I just didn't see the factoring. But it's not 16, it's 17. So.
Okay.
All right.
I have one more, and then we'll stop for now.
Okay.
So I have 3x squared. Yeah, hold on. 3x squared minus 2x. 3x squared minus 2x minus 1 equals 0. And I already know for a fact that I can't factor out, right?
Okay. I was just going to make a comment that there's a slippery line between how much time you want to try to factor it. Actually, I think it can be. That can only be that. It's plus minus. The minus is clearly going to have to be there. Now the inside is plus x. The outside is minus 3x. It gives you a total in the middle of minus 2x. And that's what we have.
So it can be factored out. Okay.
Yeah, factored into those two. And I'll solve it.
Okay. So then we have 3x plus 1 equals 0 and x minus 1 equals 0. So then we have 1 over 3 equals x.
Negative.
And 1. Yeah, negative
drop
1 over
negative
3.
signs. I know you have a tendency to drop negative signs. Everybody.
Okay.
Everybody hates negative signs. So boy, if you can drop them, they love it. If you give a person a problem with 3 negative signs in front of it, they'll drop one of them almost certainly, just because they hate them. You can't drop them. They're every bit as important as a positive sign.
Okay.
Okay. So this is minus 1/3. What's this?
Minus 1/3. That's 1. X equals 1.
There's your 2 answers. Now, let me just back up a second here. I was about to say there's a fine line between how much time you spend factoring before you give up and you go to the quadratic. If you know for sure that it can't be factored, then you immediately go to the quadratic. Don't waste any time trying to factor it. Sometimes you can't tell. I couldn't tell when I first looked at this whether it could be factored or not. So I decided to give it one shot because there weren't really many choices. It's either minus 1 here and plus 1 there, or the other way around. You know, there's only 2 choices that I had to look at. And sure enough, one of them was right. It could be factored. So this one was certainly worth the time spent trying to factor it. There are others that it isn't. You can sit there and spend 15 minutes trying to factor it, realize you can't do it, then you go into the quadratic and solve it in another 3 minutes. So you kind of have to make a choice as to how much time you're going to try to spend factoring it.
Can you take her to her cage? Can you take her to her cage? Yeah. Okay. No, I understand that.
Okay.
I get that now.
Okay.
Okay, yeah, that's like all I have for
We're going to call it a day for the day?
Do you have any more open spots tonight, or?
Sure. They're all available on there. You're welcome to go in and schedule one. Here, let me quick.
I'll check.
Oh, that's next week. Hold on. Let me get on next week. This week. Yeah, no, I gave myself a half-hour break, but anything after 5:30 is available.
Okay, cool. Thank you. I might schedule something.
Okay. Talk to you later. Bye-bye.
Bye-bye.